Hi there, this is Teacher Naihma and welcome to today's video. Today we'll be talking about the calculation of protons, neutrons, and electrons. So without further ado, I think we gotta start. So let's go over writing an isotope symbol. I hope you have learned this in our previous lesson, but if you don't remember, then we'll just review. So in writing an isotope symbol, you will have the chemical symbol right smack in the middle. So you have here the chemical symbol. And on the lower left side of this, right here, that will be the atomic number. And right on the upper part, the left upper part, that will be your atomic mass. Okay, like for example, as I've said in the previous video, for example, you have carbon. Carbon has an atomic number of 6, so we're going to write it right here. And it has an atomic mass of 12, at least for a stable carbon isotope, that is. So this is an example of your isotope symbol. Now, let's go over the rules. Now, when you talk about the atomic number actually tells you the number of protons that the element has. So that's unique per element, because if you look at your periodic table, again, each element has a unique atomic number. Therefore, the number of protons is unique per element. Take note of that. Okay, so the atomic number is basically the number of protons in an element, and the atomic mass is basically the combination of the number of protons plus the number of neutrons. Okay, now, so to get the number of neutrons, you just have to subtract, right? You just have to get the atomic mass minus the atomic number. Or that's basically n plus p minus n. Sorry, p. Okay, now what about the electrons? In an element or a given element that has no charge at all, like zero charge, you will have the number of protons will be equivalent to the number of electrons. That's for an element that has no charge at all. Now, what happens if there is a loss of electrons? So if there is an increase of electrons, now let us remember that electrons are negatively charged, okay? So they always have a war, but they always go against the protons because the protons are positive, right? So if there are more electrons than protons, so that would mean the charge would be more negative, okay? So if there are more electrons, the charge, will be more negative. Now, what if there's a loss of electrons? So if this is the electrons and this is the protons, if it gets lower than your protons, remember are positive, therefore the charge will be positive. So these are the rules that we have to remember. If we are going to go to the next couple of slides, just take note of these rules. You can write them down in your notebook. You can take a picture. Just take note of them. Okay? So let's start. Now, this is basically, this video tutorial basically is in one of your worksheets. So just take note of how we are going to answer the following problems so that you'll be able to answer your worksheets in a very timely and very proper manner. Now, for those who do not understand what Teacher Naima, what are you talking about? What worksheets? These are only for my students in the school that I teach in. So don't you worry, you will not have to answer worksheets if you're not my student. Okay, so I'm gonna put my face on the lower left because no, sorry, on the upper right because we're going to write something here. Now, on your worksheet, you will see this table. And the headings are as follows. You have your atomic or isotope symbol. You're going to write that down if it's not given. If it is given, you just have to indicate the charge, the atomic number, and the atomic mass. Okay? So you have your atomic or isotope symbol, you have your atomic number here, the number of protons, neutrons, electrons, atomic mass, and charge. Now remember, your protons is basically your atomic number. Your atomic number is basically the number of protons. Your neutrons basically is the mass minus the that's atomic mass, by the way, minus the atomic number, or basically minus the number of protons. The electrons, basically, if it has zero charge, so you will have the number of protons equal to the number of electrons. The atomic mass will be neutrons plus protons. I know this is a lot to memorize, but you just gotta practice. And the charge is basically dependent on if the electrons are more than or less than or equal to your protons. Okay, so let's start here. Now, the clue here, the clue that is given in this first item is that it has 34 protons. So what does it mean if it has 34 protons? It means that this particular element has an atomic number of 34, right? So what particular element is that? So you gotta look for your uh, periodic table and find this element. So what element is this? Now, if you're gonna go through your periodic table, you will know that the element that we're talking about is selenium. So that is selenium. So here is the atomic number and here is the mass. So you can see that the mass is 79. Okay, so we know that this is selenium, so we're going to write selenium here. And we know that its number of protons is 34. Now, let's determine the mass. The mass is already given, and that's 79. So this is pretty easy, right? But we're lacking one more information, and we are gonna talk about that later on. So you know that the atomic number for this, because it has 34 protons, the atomic number would be 34. And the number of neutrons basically is 79 minus 34. So how much is that? 79 minus 34. I'm actually looking at my calculator because I'm calculating as we go. So you will get 45. Now, how about for the number of electrons? Now, for the number of electrons, you have to look at the charge. Okay, so if the charge is 0, that means that the number of electrons is basically the same as the number of protons. So they are balanced. So therefore, if there are 34 protons, it just follows that there are also 34 electrons. Ain't that easy? So what are we going to write for the charge? We're actually going to write the charge here on the upper right corner of this symbol. However, if we look at the charge given here, it's 0. So that's negligible. Doesn't have a charge. Therefore, you're not gonna write anything there. Okay? So let's go to the next item. So let's look at the next item. Now, you're given already the symbol. So you know it's lead, right? It's Pb. So lead has 82 protons, so basically it has an atomic number of 82. Just makes sense, right? Now, what about the neutrons? Okay. Now, if you're going to look at if you're going to look for the neutrons, you must have to have the atomic mass. Wait a minute. Okay, so if you look at the atomic mass of lead, it is 207. So 207. So basically, to get the number of neutrons, that's basically 207 minus 82. So how much is that? 207 minus 82. How much is that? I'll let you calculate. That's 125. Okay. Now, the thing is, before we answer the electrons, we have to look at the charge. The charge here, according to what is given here, the charge is plus 2. That's positive 2. Now, what does that mean? If this is the electron and this is the proton, which is higher? Is it electron or proton? It's positive, remember. So, which is higher? It would be the proton. Why? Because the proton is positively charged. So there will be a higher number of protons. How many? Only 2. Therefore, the number of electrons will decrease by 2 electrons. Now, if you remember, I told you that the number in a chargeless element, the number of protons is the same as the number of electrons. But in this case, because it has a charge of positive 2, the number of electrons will be lower by 2. So since there are 82 protons, you just gotta subtract 2. So 82 minus 2, you will get 80. So that's it. That's it for lead. Okay. Now what about this one? It's only the atomic number and a number of electrons given. Now, it just makes sense, right? Oh, wait a minute. Let's go back. No, we haven't written the whole isotope symbol. I am very sorry about that. Now, lead, the atomic number of this would be 82. The atomic mass would be 207. And the charge would be positive 2 or 2 plus. So that's how you're going to write the isotope symbol for a lead that has a charge of positive 2. Okay, let's go to the next one. Now the next one has an atomic number of 24 and the number of electrons will be 21. So there is a discrepancy. So you know that the charge will be not 0. You know that already. So because the atomic number is 24 and that is basically also the number of protons, you're going to write it here to 24. Now, if you're going to look at the periodic table of elements, which element has an atomic number of 24? That would be chromium right here. So that is 24 right here. So we're going to write chromium right here. Now, according to your periodic table, chromium has an atomic mass of 51.9, but we'll just convert that to 52 because it's very, very close to 52. So it has an atomic mass of 52. Therefore, how many neutrons will there be? So that's 52 minus the number of protons, that's 24. So how much is that? So there's 28. Is that correct? Yes. I'm doubting myself. I'm so sorry. So we got it all covered. Now what about for the charge? Now if you look at the number of protons and the number of electrons, which is higher? Is it the proton or the electron? Which is higher? Proton is higher. The number of protons is higher. So this would be positive The charge will be positive. Now, by how much? The next question is by how much? So 24 minus 21, you will get 3. So the charge for this is positive 3. That means it has 3 less electrons. So we're going to write the isotope symbol. Chromium will have an atomic number of 24, and it will have an atomic mass of 52, and its charge right here would be positive 3, or 3 plus. So that's it for chromium. Now, what about for the next example? We have phosphorus right here, and phosphorus has an atomic number of 15. So that just makes sense that the number of protons would be also 15. So we know that. Now, the charge is negative 3, so we're going to find out how many electrons there will be later on. So if you look at your periodic table, according to your periodic table, the mass or the atomic mass of phosphorus is 30.974, or we will just convert that to 31. Okay, that's 31. Now, what's next? What do you want to figure out next? Okay, so let's figure out how many neutrons there are. So that's 31 minus 15. So 31 minus 15, that would be 16. Okay, so we have it all covered. Now, next we'll figure out how many electrons there are, because its charge is negative 3. So if its charge is negative 3, if this is electron and proton, which will be higher? Of course, it will be the electron, because its charge is negative 3. So higher by how much? That's the next question. The electrons are higher by how much? So 15, there are 15 protons. You're going to add 3 more because charge is negative 3, right? So 15 plus 3, you will get 18. So that will be 18 electrons all in all. So if you're going to write the isotope symbol, it would look like this. Phosphorus has 15 protons, so therefore its atomic number will be 15. Its atomic mass will be 31, and its charge will be negative 3. So that will be its isotope symbol. Okay, what about the next one? You are given the chemical symbol Rb, and with the atomic mass of 85 and the charge of +1. So if you're going to look at your periodic table, you will get 37 protons for Rb. So 37 protons, therefore, how many, not how many, but what will be its atomic number? It will still be 37. Now, because the atomic mass is already given, you just have to subtract 35 minus 85 minus 37. So what will be the number of protons? So we are going to get, wait a minute, I'm still calculating. We are going to get 48. Okay. Now next, we're going to figure out how many electrons there are. Now if you look at the charge will be positive 1. Now since it is positive, that means there are less electrons here. By how much? That will be 1. Okay? So if there are 37 protons, the number of electrons will be 1 less than the proton. So that would be 37 minus 1. So that will be 36. So if you're going to write the isotope symbol of this particular rubidium, you will get the atomic number 37 right here, the atomic mass of 85, and the charge of 1 plus, or Actually, you can just write it down as just plus. That's it. Okay, so we're done with rubidium. Now next one. Next one, we're not given any symbol. We're just given the number of electrons and the atomic mass of 131. But the thing is, Teacher Naihma, how are we going to determine what element that is? That's pretty easy. Why? Because if you look at the charge is 0. Therefore, there is no loss nor gain of electrons. So therefore, the number of electrons will be the same as the number of protons. So if the number of electrons will be 54, the number of protons will be the same. That will still be 54. And the number of protons dictates your atomic number. Therefore, the atomic number is 54. Therefore, the element that we're looking for is atomic number 54, and that is xenon. So we're going to write here xenon. Now, what about for the neutrons? That is 131 minus 54. Okay, so how much is that? You will get 77. So that's pretty easy, isn't it? So if you write the isotope symbol, you'll get xenon 54 and atomic mass of 131 and then the charge of 0. So we're not going to write down the 0 anymore. So that's it. That's very straightforward. And then this one right here, we have the chemical symbol Hg. So Hg is mercury. So if you look at your periodic table, you'll get these details right there. And then according to your details, mercury has an atomic number of 80, which is the same as the protons. Yeah. And then the atomic mass of 200.59, but you will just convert that to 201. Okay. So for the neutrons, we will get 201 minus 80. So how much is that? So you'll get 121. So what about for the charge? Now, if you look at the number of protons versus the electrons, which is higher? Is it protons or is it neutrons? I'll give you time to think. Of course, the higher is protons. So that would be positive. The charge will be positive. But next is by how much? So what is the difference? 80 minus 78. So how much is that? 2. So plus 2. So if you're going to write the isotope symbol, it would look like this. Hg, atomic number of 80, atomic mass of 201, and then a charge of 2 plus. So that's it. So that will be all for protons, neutrons, and electrons. It's not a very complicated concept, but I think it would need you to take time to practice because there are a lot of rules. And I know that a lot of you don't really like rules. So just take time to practice. There are very many items in the worksheets that I've provided. And for those who are not my students, you can just look for examples on the internet. There are a lot of them. And you can take time to practice and practice that skill so that when you answer your quizzes and your homework, it will not be as hard as you have imagined. So thank you so much for watching. And always remember that you have to believe in yourself, right? Because we're all in this together. So if you have questions for me, you can just post your comments right below this video, or for my students, you can message me on Messenger and on Gmail. So I hope this was helpful, and I'll see you on our next video. Goodbye for now.